Okay, students, so let's start with the theory past papers of forces. This is applicable for O levels and IGCSE both. In a safety test, a car of mass 1100 kg travels at a speed of 10 ms minus 1 and collides with a stationary van of mass 3000 kg. Okay. After the collision, the car and the van move together with a velocity v. Okay. Figure 2.1 shows the car and van before and after the collision. Okay, so this is the scenario before collision, and this is basically your scenario after collision. Okay, the total momentum of the car and the van is conserved during the collision. Okay, define momentum. What is actually momentum? Momentum is the product of mass and velocity. Momentum is the product of mass and velocity. State the units of momentum. I have told you two units of momentum kg ms minus 1, or you can write newtons seconds. Both are the units of momentum. Calculate the velocity v of the car and van after collision. So what can we apply? We can apply law of conservation of momentum. Total momentum before collision is equals to total momentum after collision. Okay. What will be your total momentum before collision? 1100 kg car multiplied by the velocity, that is 10, plus 300 kg van, that is at a velocity of 0. Your momentum after collision will be what? Mass of 3000 kg plus 1100 kg, because they are both connected together, multiplied by the velocity v, 1400 v. This entire thing will become what? 0. Okay. 1100 multiplied by 10 divided by 4100, the velocity comes out to be 2.68 ms minus 1. Simple as that. Calculate the total kinetic energy of the car and the van after collision. So what is the formula of kinetic energy? Kinetic energy is equal to 1 upon 2 mv square. What is the total mass of the car and the van? 4100. What is the velocity? 2.68 square. Okay. So let's take a square here multiplied by 4100 divided by 2. This gives you an answer of what? Kinetic energy is 14800 joules. Simple as that. Let's further move ahead. State the transfer of energy that occurs during this collision. Okay, what is happening? What is the energy transfer during this collision? Obviously, as you can see, the cars are getting attached to one another. So when they will get attached here at this point, at the point of collision, there will be some amount of heat release. So you can say kinetic energy gets converted into thermal energy released at the collision. Thermal energy release, simple as that. Or if you want to just write kinetic energy converted into thermal energy, that will also give you a one-on-one here. This was a one marker question. Let's move on to the next question. Figure 2.1 shows a man of mass 80 kg standing in a lift. Okay. The gravitational field strength is 10. Okay. Calculate the weight of the man. You have to calculate the weight of the man. Again, very easy. Weight is equals to mg. Your mass is 80. You are set to take the gravitational field strength as 10. Your weight comes out to be 800 Newton. Okay. The lift accelerates upward at a uniform acceleration of 0.5 ms minus 2. This is your acceleration. Calculate the resultant force upwards. The resultant force upward will be equal to what? ma. What is your mass? Your mass is 80 kg. Okay. Multiply this 80 by your acceleration, that is 0.5. What does your resultant force come out to be? 0.5. This equals to 40 Newton. Your resultant force comes out to be 40 Newton. Okay. The force exerted on the man by the floor of the lift. Okay. So if you observe here, there are two forces that are acting. First is the weight that will act like this. This is the downward force, and there will be forces that act upward due to the floor on the man. And we know upward forces are greater. Upward force minus the downward weight force should be equal to what? Should give you the resultant force, that is 40 Newton. What is your upward force? You don't know. What is your weight? 800. Can you calculate the upward force? Yes, upward force is equal to 840 Newton. Let's further move ahead. The lift accelerates upwards uniformly from rest for 4 seconds. Okay. So for the first 4 seconds, your lift is accelerating upwards. Okay. If you are accelerating upward, that means your velocity is increasing. And you know the gradient of distance time graph is equals to what? Velocity. If velocity is increasing because you are accelerating, that means what? Your gradient will also increase till 4 seconds. So basically, you will have somewhat like this, an increasing curve like this. Okay, let's draw it in a more precise manner. Somewhat like this. Yeah, an increasing curve. Maybe I should draw again. Let's mark a point here and let's draw an increasing curve like this. Okay, and then decelerates uniformly for the next 4 seconds. If you are decelerating, that means what? Your velocity is decreasing. If your velocity is decreasing, gradient of distance time graph is decreasing. If gradient of distance time graph is decreasing, you draw a decreasing curve like this, somewhat like this. Let me correctly make it. Somewhat like this. Yeah. So that's it. Let's move on to the next question. The turning effect of a force is measured by its moment. Okay. Figure 8.1 shows a force F acting on an object at point V. Okay. The object is free to rotate about an axis at x that is perpendicular to the page. Okay. Write down an expression for the moment of F about the axis x. Okay. Draw on figure 8.1 to show what is meant by any other term used in your expression. Okay. So if you want to calculate the moment of force F, that will be equal to what? Force F into the perpendicular distance between the force and the pivot. So this can be your perpendicular distance d. This can be your perpendicular distance d. Simple. Let's also define it. D is your distance, or you can say D is your perpendicular distance. Perpendicular distance. Perpendicular distance between force and pivot. Force and pivot. Simple as that. Let's see part B, I1. State the principle of moments. Okay, what are principle of moments? So you will say for an object to be in equilibrium, to be in equilibrium, the sum of clockwise moments, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Must be equal. For an object to be in equilibrium, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Simple as that. Anti-clockwise moments. Okay. Let's see the next question. I think those who have seen the lectures before going through the past papers will know that we have already done this question in the lectures. Describe an experiment to verify the principle of moments. Include a diagram to help the description. So what do? We take a ruler or rod like this. We then pivot this rod at the center. Okay. And then we hang a weight of we hang a weight of W1 at a distance of D1. Okay. So what have we done? We have hanged a weight of W1 at a distance of D1. This will generate which type of moments? This will generate anti-clockwise moments. To balance this out, you will place an other weight here. To balance this out, you will place an other weight here equal to W2. And you will move this weight forward and backwards until your rod balances. Once your rod balances, you will measure this distance d2. And this w2 is creating moments in which direction? Clockwise direction. So, how will you write this? You will say, take a ruler, take a uniform ruler or meter rule, take a uniform meter rule and pivot it at its midpoint. At its midpoint. Secondly, what will you say? Secondly, what will you say? Apply a weight W1 at a distance D1. This causes the meter rule. You can only write rule. This causes the rule to rotate anti-clockwise direction, in an anti-clockwise direction, to rotate in an anti-clockwise direction, in an anti-clockwise direction. Okay. What will be your third step? Place an other weight W2 and adjust its position until the rod balances, until the meter rule balances. And once the meter rule balances, what will you do? Measure distance d2. If anti-clockwise moment is equals to clockwise moments, your principle of moments is satisfied. If anti-clockwise moment is equals to clockwise moments, that is, if W1 into D1 is equals to W2 into D2, your principle of moments is verified. Simple as that. I would prefer that you write the wordings that I have given in the notes as well. Please go through that as well. Let's further move ahead to question number 6. Figure 2.1 shows a man pushing a heavy box with a force P. A frictional force F acts in a horizontal direction. The forces on the box are balanced. The box is stationary. State what is meant by balanced forces. By balanced forces, what do we mean? Equal and opposite forces. Or what else can you say? By balanced forces, what do you mean? By balanced forces, you mean no resultant force. Simple as that. Let's move on to part 2. The frictional force in figure 2.1 does not produce any heating effect. State what must happen for the frictional force to produce heating. The box must slide. The box must slide. Okay. Apart from being stationary, state one other possible state of motion of the box when the forces are balanced. What is one other possible state of motion where forces are balanced? Constant velocity. At a state of constant velocity, the forward forces are equal to backward forces. This also represents a position where forces are balanced. When P is 100 Newton, F is 85 Newton, the box accelerates. The mass of the box is this. Calculate the acceleration of the box. You have to calculate the acceleration of the box. Your P is 100, F is 85. What will be your resultant force? Resultant force is 100 minus 85, that is equals to 15 Newton. Your mass is 25. Can you calculate the acceleration? F is equals to ma. 15 is equals to mass 25 into acceleration. 15 divided by 25 is your acceleration. What does your acceleration come out to be? 15 divided by 25. It comes out to be 0.6. 0.6 ms minus 2 is your acceleration. Simple as that. Let's move on to the next question. A car of mass 800 kg is traveling at a speed of 25 ms minus 1 along a straight horizontal road. State how velocity differs from speed. Velocity is a vector quantity. Velocity is a vector quantity. Hence, it has a magnitude. It has a magnitude and direction both. It has a magnitude and direction both. Let's further move ahead. Let's see part B. The driver presses the accelerator and the speed of the car starts to increase from this. Okay, this is your initial speed. The car accelerates at this. This is your acceleration. Calculate the resultant force acting on the car as it accelerates. So, what is the formula of resultant force? F is equals to ma. What is the mass of the car? 800. Okay, so 800 multiplied by 1.5. This comes out to be what? 800 into 1.5. This comes out to be 1200 Newton as your resultant force. Explain why the forward force acting on the car due to the engine is greater than the value calculated in BI1. Why is the forward force acting on the car is much greater than the resultant force that we have calculated here? Because in real life, the friction forces between the between the car between the tires and the road, you can say that, due to the frictional forces between the tires and the road, and plus air resistance causes a backward force. And if there is a backward force, there must be an even greater forward force to overcome that. Okay. The frictional forces between the tire and the road plus air resistance causes a backward force. Hence, we need a forward force that is greater than this 1200 value. Determine the speed of the car after 4 seconds after speed of the car 4 seconds after it starts to accelerate. So you have the time, you have the initial velocity that is 25 ms minus 1, you have the time that is 4 seconds. Your acceleration is what? Your acceleration was 1.5. Can you calculate the final velocity? Yeah, you can surely do that. V is equals to u plus 80. U is 25. Acceleration is 1.5 into 4. This becomes 31 ms minus 1. 31 ms minus 1 is your final speed. State what is meant by friction. A force opposing the motion. A force opposing the motion. Simple. Motion of the object, you can say that. Motion of the object or body. Let's further move ahead. Figure 2.1 shows two horizontal forces act on a car. Force B is caused by air resistance and friction. Okay, force B is caused by air resistance and friction. This is your air resistance and friction. The car is traveling along a straight level road. The forward force A and the backward force B are equal. Describe the motion of the car. If both the forces are equal, resultant force equals to 0. Resultant force becomes 0. Car travels at a constant speed. Car travels at a constant speed. Simple. Let's further move ahead. The mass of the car is this. Force A increases to 5000 Newton. This causes the car to accelerate initially at this value. Calculate the size of force B. Okay. If your acceleration is this, mass is this, can you calculate the resultant force? Yes, resultant force is equals to mass into acceleration. Mass is 800, acceleration is 1.5. Your resultant force comes out to be 1200 Newton. Okay. Now, what will your resultant force be equal to? Force at A. Let me take this color. Yeah. Force at A minus force at B will be your resultant force. So, what can you say? Force at A minus force at B is equals to your resultant force. What is your force at A? 5000 Newton minus the force at B is equals to your resultant force of 1200. Bring 1200 to the other side. 5000 minus 1200 is equals to the force at B. The force at B is 3800 Newton. Force A remains constant at 5000 Newton. Explain why the acceleration decreases as the car travels along the level road. Why will the acceleration decrease? Because as the car gains speed, as the car gains speed, backward force, or you can say resistive forces increase. And as resistive forces increase, what will happen? Resultant force will decrease. As resultant force decreases, your acceleration decreases. Why? Because of the formula F is equals to ma, force is directly proportional to acceleration. If resultant force decreases, acceleration is bound to decrease. A car of mass 800 kg climbs a hill and rises a vertical distance of 200 meters. Calculate the gain in potential energy of the car. So, how will we do that? mgh. Your mass is 800, your g is 10. You have to take g as 10. Your vertical height is 200. So, 800 into 10 into 200. This comes out to be 1600 three zeros. 160030 joules. Simple as that. Let's move on to the next question. A worker carries a ladder on his shoulder. His shoulder acts as a pivot. Figure 8.2 shows that the ladder is horizontal. Okay. The ladder is wider at one end than the other. The mass of the ladder is 8 kg. Okay. This is the center of mass. So the weight might be acting from here. So this is 8 kg. Calculate the weight of the ladder. Yes. The weight of the ladder will be what? 8 into 10. That is 80 Newton. And this weight will be acting from here. Okay. Let's further move ahead. State what is meant by center of a mass. A point where the entire mass of an object, where the entire mass of an object seems to be acting. Seems to be acting. Simple as that. Let's see part 3. The center of mass of the ladder is not halfway along its length. State what this shows about the ladder. This basically shows that the mass distribution in the ladder is not even. So you can write here mass distribution along the along the ladder is uneven, or you can say not even. Either way works. The center of mass of the ladder is a horizontal distance of 0.9 meters from the worker's shoulder. Calculate the moment about the worker's shoulders of the weight of the ladder. Okay, so we have to calculate the moment of this weight. This is the force. This is the distance. This will generate which type of a moment? This will generate a clockwise moment. So let's write it down. Moment is equals to force into distance. Your force is your weight of 80 Newton. And what is your distance? 0.9. Let's multiply it. 80 into 0.9, this will become what? 80 into 0.9, this becomes 72 Newton meter. Simple as that. A bucket of weight 87 Newton is suspended from the ladder at a horizontal distance of 1.3 meter from the worker's shoulder. Okay. The worker keeps the ladder horizontal by applying a vertical force at the point L. L is a horizontal distance of 0.54 meter from his shoulder. Okay. Determine the size and direction of the force at L. Okay. So basically, if you are keeping the ladder horizontal, that means what? Anti-clockwise moments must be equal to clockwise moments. Okay. Currently, the weight of the ladder is generating clockwise moments. Let's see what the bucket is doing. Let's see what the bucket is doing. The bucket has a weight of what? 87 newtons. And it is a distance of 1.3 meters from the shoulder of the person. So the anti-clockwise moments will become what? The anti-clockwise moments will be what? 87 into 1.3. Let's calculate that. 87 into 1.3. This comes out to be 113.1 Newton meter. So these are your anti-clockwise moments. Anti-clockwise moments is equal to 113.1 Newton meter. The clockwise moments are 72 Newton meter. Okay. And if you want the ladder to be horizontal, you want the clockwise moment to be equal to anti-clockwise moment. So basically, if you are applying a force if you are applying a force L, this will generate anti-clockwise moment. And it will generate clockwise moment. See, basically, you have a deficiency in which type of moments? Your clockwise moments are 72 and your anti-clockwise moments are what? 113.1. So there is a deficiency in which type of moments? Clockwise moments. So your force L should generate clockwise moments at this point. So if the force L wants to generate clockwise moment, where should it act? It should act downward like this. It should act downward like this. This should be your force L. So now you have the direction. This will generate clockwise moments as well. Okay. Now what will be the value of this clockwise moment? Let's calculate that. Let's calculate that. What is the deficiency, or you can say the difference in the anti-clockwise and clockwise moment? 113.1 minus 72. This gives you an answer of 41.1. So this should be your extra clockwise moments. Your force is L. What is your distance? I guess the distance is, 0.54. The distance is 0.54 meters. Okay. So let's multiply this L force with 0.54 meters. 41.1 divided by 0.54 is your L. 0.54. This gives you an answer of what? 76.1 Newton. 76.1 Newton. This acts downwards like this. Okay. Let's move on to the next question. A glass beaker has a mass of this. A liquid of density this is poured into a beaker until it reaches this volume. Calculate the total mass. What will be the total mass of the beaker and its content? First of all, the mass of beaker is 50 grams. Plus, what will be the mass of contents? The density, that is 1.8, multiplied by the volume, that is 200. So 1.8 into 200, 360 plus 50 grams, 410 grams is your total mass. The center of mass of a meter rule is at the 50 cm mark. Okay, what is meant by center of mass? A point at which, the entire mass of an object seems to be acting. Of an object seems to be acting. Seems to be acting. Simple as that. Let's further move ahead. The meter rule is planted on a pivot. Okay, the meter rule is planted on a pivot. The tip of the pivot is under the 80 centimeter mark of the rule. The beaker with its contents is placed at different positions along the rule until the rule is balanced. Figure 1.1 shows the arrangement with the rule balanced. Okay, this is the 50 centimeter mark. This is your pivot, and the weight will be acting from here. How do I know that? How do I know that? The beaker with its content is then placed at different position along the rule. Figure 1.1 shows the rule balance. That means what? Anti-clockwise moments will be equal to clockwise moments. One side of the beaker is at 84 centimeters. So let's say this is 84. Yeah, it is already marked. This is 92. What will be the center here? 84 plus 92 divided by 2. 88 centimeter is your center here. This is the point through which the weight of the beaker will act. This is the weight of the beaker and its content. Let's label it WB. You have to calculate the mass of the ruler. Very, very easy. Very easy. First of all, what is the weight of the beaker and its content? The total mass of the beaker and its content is 410 grams. So the weight of beaker will be 0.41 and Are we given any value of gravitational field strength? Let me see. No. Can you see in this entire question we are not suggested any value of gravitational field strength? If you are not given any value of gravitational field strength, you will take your gravitational field strength as 9.8. Your weight of the beaker and contents comes out to be what? 4.018 Newton. Okay, so this beaker weight is causing a movement in which direction? It is causing a movement in the clockwise direction. So force is 4.018 Newton multiplied by the distance, that is 8 centimeter. Okay. And this weight, this force of weight is causing a movement in which direction? Anti-clockwise direction. Weight multiplied by this distance, 50 to 80, that is 30 centimeter. You might notice that I haven't converted centimeters here. Neither have I converted 8 centimeters into meters, neither have I converted 30 centimeters into meter. Because both the units will get cancelled out. Let's say I divide this by 100, let's say I divide this by 100, they will cancel out. Simple. No effect. Okay. Can I calculate weight? Yes. 4.018 into 8 divided by 30 is equals to your weight. So into 8 divided by 30, your weight comes out to be 1.07 newtons. But you have to calculate the mass of the ruler. So weight is equals to mg 1.07. Mass is equals to 1.07 divided by 9.81. Let's divide it 9.81. This comes out to be 0.109 kg. This comes out to be 0.109 kg. Simple as that. This is a partition. Okay. Let's further move ahead to the next question. Figure 1.1 shows a model of the human arm. Okay. The rubber band represents the muscle that moves the part of the arm XY up. Okay. A mass is suspended from XY as shown in figure 1.2. Okay. The weight of the section XY is negligible. Okay. So the weight of this section XY is negligible and the model is at rest. So the weight of this section, this entire rod, is considered to be negligible here as well and here as well. At both these places, the weight of XY rod is considered to be negligible. And if the model is at rest, that means anti-clockwise movement is equals to clockwise movement. State two ways in which the dimensions of the rubber band change as the mass is added to the section XY. If you keep on adding masses here, 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 what will happen? Your rubber band will get thinner and it will stretch and get longer. Simple. State the form of energy stored in the stretched rubber band, elastic potential energy. Elastic potential energy. State principle of conservation of moments. We have already done this. We have done this definition in the notes as well. So you can copy it from there or you can scroll back in the video. We have done a similar question. Explain why the force that the rubber band exerts on XY is larger than the weight of the mass. Okay. So the examiner is asking, why will a force here, that is a force of the rubber band, will be greater than this weight? Why? If you can notice, the object is at rest. That means anti-clockwise moments will be equal to clockwise moments. This force F is generating what? This force F is generating anti-clockwise moments. And this weight is generating clockwise moments. Can you observe weight that is causing the clockwise movement is much further away? It has a greater distance, let's say d1. And this force F in the rubber band has a very small distance, let's say d2, highlighted in blue. So let's say this is your d2, that is 2 centimeter, and this entire highlighted thing is, let's say, your d1. Can you see d1 is much greater than d2? Hence, to cause the same moment, weight will be much less compared to F. To put my words mathematically, have you studied this equation of moments? Moment is equals to force into distance. Okay. Now here moments get constant. Why? Because anti-clockwise moment is equals to clockwise moment. So moment over F is equals to D. If moments get constant, what will happen? If this force of moments get constant, what will happen? Force will be inversely related to distance. If the distance of W is greater, W itself will be less. If the distance of F is smaller, F itself will be greater. So you can write here, you don't need to write this entire story. You can just say the force in a rubber band, the force, however, you can rephrase it like this: the force, the distance, you can rephrase it like this: the distance between the force by the rubber band and pivot is much less. The distance between the force by the rubber band and the pivot is much less. Hence, to generate the same moment, you need a greater force. You need a greater force. Oh, you need a greater force. You need a greater force. Simple. The mass suspended from XY section in figure 1.2 has a weight of 4 Newton. Okay. Calculate the force that the rubber band exerts on XY. Okay. So this is easy now. We have already studied this. So if you see, let me clean this up. This mass has a weight of 4 Newton and this will cause which type of a moment? This will cause clockwise moment. Okay. This rubber band has a force F upwards. This will cause which type of a moment? Anti-clockwise moment. So this force F is at a distance of 2 centimeter. This weight is at a distance of 16 plus 2, 18 centimeter. So what can you say? You can say clockwise moments is equals to anti-clockwise moments. What is the force causing clockwise moment? 4 Newton at a distance of 16 plus 2, that is 18. 4 into 18. What is the force causing anti-clockwise moment? F at a distance of 2 centimeter. Okay. Again, I haven't converted the centimeters into meter because I hope you understand. If I divide this by 100, divide this by 100, both of them will get cancelled out. 4 into 18 divided by 2 is your force. This becomes 1, this becomes 9. 36 Newton is your force F. 36 Newton. Explain how your answer to part B3 is different if the weight of the section XY is not negligible. Can you see, before starting this question, we have made a very big assumption that this entire region has a negligible mass, which is very absurd. If that is not the case, its weight will also generate a clockwise moment. Its weight will also generate a clockwise moment. Hence, your anti-clockwise moment must also increase. Your force in the wire XY must increase. So, how will you state that? If weight of XY is not negligible, it increases the clockwise moments. Hence, anti-clockwise moment increase, causing the force in XY to increase. Simple as that. I hope you get the logic. Now let's move on to the next question. Figure 3.1 shows a door and an automatic door closer viewed from above. Okay. When the door opens and closes, the hinge acts as a pivot. Okay. So this thing basically is a pivot. Okay. A girl opens the door by exerting a force P at point X. Okay. Force P is perpendicular to the surface of the door. Okay. Figure 3.1 shows that point X is a distance of 0.72 meters along the front of the door from the hinge. The force P is 25 Newton. Okay. So this force P is 25 Newton. The distance is 0.72 Newton. Can you calculate the moment? Yes. Moment is equals to force into distance. Your force is 25. Distance is 0.72. This comes out to be what? 25 into 0.72. This gives you an answer of 18 Newton meter. Okay. The door rotates about the hinge by 90 degrees. The circumference of a circle of radius 0.72 meters is this. Calculate the work done by force P. Okay, we have to calculate the work done by force P. So basically, the door is rotating by how much? By quarter of a circle. So we can take the quarter of the circumference. The circumference, to calculate distance, what can we do? We can take the quarter of the circumference, 4.5 divided by 4. Why? Because the door is only rotating by 90 degrees. And how many degrees are there in a complete circle? 360. So you are basically rotating 1/4 of a circle. So your distance will be what? 1/4 of a circumference. Your force is what? Your force was 25. Okay. Can you calculate the work done? Yes. 25 force into 4.5 over 4. That is your distance. 4.5 divided by 4 into 25. This gives you a value of 28.1 joules is your work done. Simple as that. Nothing complicated here. As the door opens, there is a force F on the door in the direction shown in figure 3.1. Although F is larger than P, the door rotates about the hinge. Explain why. So again, same logic. The examiner is saying, let's say this force is 10 Newton. Sorry, not 10 Newton. Let's say this force is somewhere a value greater than 25 Newton. What should we give here? Let's say 40 Newton. The examiner is saying, although force F is 40 Newton, but still the door rotates in the anti-clockwise direction, like this, in the direction of the force. Why is that the case? Because although force F is greater, but its distance from pivot is less. So the door rotates in the direction of force P. You can write this. You can write this. Although force F is greater, force F is larger, but the distance of force F from pivot is smaller. Hence, the anti-clockwise moments, or you can say not anti, not let's not complicate it. You can say hence the door rotates in the direction of force P. In the direction of force P. Simple as that. Okay, let's see this question. A sports car is designed to be very stable when turning a corner at high speeds. Okay. Figure 2.1 shows the position of the center of mass of the car somewhere here. Okay. State what is meant by center of car. Center of mass. We have already done this twice, I think, in this video. So I am not wasting time. State two features of the design that make the car stable. First of all, lower center of mass. Lower center of mass. And secondly, wider base area. Simple as that. Let's further move ahead. Figure 2.2 shows an irregularly shaped piece of card. Okay, so this is an irregularly shaped piece of card. Describe how to determine the position of the center of a mass of the piece of card. You may draw a diagram on figure 2.2 in the blank page. Okay. So basically, you will perform what? You will perform a plumb line experiment, somewhat like this. Let's say this is your irregularly shaped object. You will mark 3 holes. You will suspend a plumb line from each of them. And once you have suspended a plumb line, you will mark a dotted line once the plumb line settles or comes to rest, like this. The point where all the dotted lines meet is your center of mass or center of gravity. This plumb line experiment is written in great detail in notes, so yeah, you can copy it from there. This marks the end of the past papers for forces. If you have any questions, you can ask.